Sound check. Sound check. All right, hi guys. Welcome to our merit question a day live. And if you have any questions, pop them into the chat or just say hi. Let me know that you're here. It's always nice if somebody does drop in while I'm doing it. Okay, so we've got our 3 lots of merit questions. I posted these to Instagram yesterday. So if you do want to do the questions before I start going through them, then you can just check my Instagram each day as we lead up to the calculus exam. That's probably the best idea for getting the most out of these sessions. If you're watching this back on record, then pause it and have a go at the question before I start going through them. Okay, so let's take a look at the complex numbers one. So we've got the this equivalent set of fractions here, and we need to work out a, b, and c to make this thing be true. So what I'm going to do is use the right-hand side of that, put it all over a common denominator. Let's move this over a bit. So that would, if we were to combine these 3 bits here, then we would put them over a common denominator of x squared x minus 1. They would all fit into that. Now the a term is already over a singular x. So to make it be over this common denominator, we'd need to times it by another x and the x minus 1 bracket, so that it would be equivalent. For the b, on the denominator there, we already have the x squared, so we need to times it by the x minus 1. And for the c, sorry, I was just checking everything was set up right. We have the x minus 1, so we need to times it by the x squared. And that's equivalent to the left-hand side that we had like this. Which means that if those two denominators are the same, then the numerators are equal to each other. So we have, on the left-hand side, if I multiply that out, we get ax squared minus ax plus bx minus b plus cx squared is equal to 1. Now let's just compare the left and the right with the different portions that are in there. So we have x squared terms, we have x's, and we have constants. Now I'm going to start with the constant simply because on the right I only have a constant. So if we compare constants, on the left-hand side we only have this minus b. So minus b must be equal to 1, or b equals minus 1. Now if we compare the x terms, then on the left we have x terms here, and on the right we have 0 x terms. So we have minus a plus b is equal to 0. Well, b we just worked out to be minus 1. So then a must be equal to minus 1. Finally, we'll look at the x squared terms, and for these, on the left we have ax squared and cx squared, and on the right again we have none. So we'll set those equal to each other. A plus c is equal to 0. A we just worked out to be minus 1, so c must be 1. And there's our 3 values for a, b, and c. A, b, and c. All right, I'll just flick over to the marking schedule and see where we got the achieved point within that. So I'm just trying to find that one. Okay, so doing the expansion. This line just here was where we got achieved. Okay, So now let's move on and have a little look at differentiation. Now, I really, really like these questions with the graphs. They're just one of my favorite things to do. I can just pick out from the picture exactly what it is I'm looking for. So then if we take a look at the first term, oh, I think I've just wobbled the camera. Just give me a sec. Let me just pop that back. Got it precariously balanced at the moment. All right, so we want to know the first place where f of x is not defined. So take a look at this graph here. Let me see if I can zoom in as much as possible. For it to be not defined, we're looking for anywhere where on the graph, if we were to put in an x number, we wouldn't be able to find an answer for what y would be. And the place that that happens is, sorry, I'm missing a mouse today. So we wouldn't be able to figure that out on this asymptote down here. Everywhere else we can find where it would be. So like here, even though there's a gap, we do have a filled in circle, so we'd know that it was just there, and similarly on this one. But this, where the asymptote is, that then we don't have a definition of what the y value would be. So that happens when x is 1. Okay. Then we're looking for where is f of x not differentiable. Then, it's not differentiable where we couldn't define the graph. It's also not differentiable anywhere that there's a break or a sudden kink to the graph. So we have a break just here at -1. We have the break here on the asymptote, and we have a break here at 2. So we have -1, 1, and 2. For f double dash of x is greater than 0, that means it is part of a minimum. It's not exactly at the minimum point, because that would be when the first derivative is equal to 0. But with the second derivative equal to 0, it's any part of the graph that is part of a minimum. So we're looking for a portion that's part of of a right way up bowl, and that comes from this bit just here. So what we're looking for there is -1 up to 1, because it'll stop when we get to this line here and we hit the asymptote. But this indicates that it goes on forever until it hits the asymptote. Or doesn't hit it, but, gets as close to it as is mathematically possible. Okay, finally, what is the value of f of -1? So we look to our graph. If x is -1, -1, just here. Reading up the graph here, we don't want anywhere where there's a hole. So we're not going to take that gap, that one just there where it's got a gap in it. We're looking for solid portions on that line. So that's that one just there. In that case, y is equal to 3. Now the limit as we approach 2, as we come towards 2 from the left, we're heading towards a value of 2. From the right, we're heading towards a value of 3. Now, because they don't match up, that means we don't have a limit. So it says does not exist. So to get a limit, they have to go towards the same finite number from both the left and the right. Now, achieved on that one, you needed to get 2 of them correct. So 2 correct for achieved and 4 correct for merit. So you didn't even need to get all 5 pieces correct for the merit. Now the bad news about these ones is on the last couple of years of papers, these ones haven't been worth a merit. They've sort of been downgraded a little bit, had less parts to them, and then they've only been worth an achieved in the last couple of years. Okay, still a really great question though, that I do enjoy doing, but it's unlikely it's going to be worth a merit anymore. It could still appear like this, and it was a merit on the year that this was put into the paper, which is why I have used it today. Okay, final one for today, we have integration. We've got kinematics on this one. We've got the rate at which the velocity is changing, so dv by dt, given by this equation just here. Now, to work out the velocity of the object is what we're being asked for on this one. We would need to integrate that. I'm just going to shrink this down a little bit and do that. There we go. All right, now to find the velocity, we're going to need to integrate dv by dt, but before I do that, I'm going to simplify it. So if we take 50t squared over 5t to the half minus 80t to the half over 5t to the half. So all I'm doing here is separating that fraction into two different pieces. So now I can do some simplifying. So the t to the half obviously cancels. Oh, I missed out the 0 on 80. There we go. 5 and 50 cancel to just be a 10. If we're dividing powers on this bit just here, division of powers means that we're subtracting. So what we'll end up with is this becomes 10t to the 2 take away a half, which is 3 over 2, minus 80 over 5, which is 16. So now we're integrating 10t to the 3 over 2 minus 16 with respect to t. Okay, t, increase it by 1 and we get 5 over 2. If we do 10 divided by 5 over 2, it's the same as timesing by 2 over 5. So we have 20 over 5. That gives me 4. Minus 16t plus c. Now, let's get some information from the question. We have the original velocity was 6. So when we start at t equals 0, v equals 6. And that's going to help us to work out the c. So 4 times 0 to the 5 over 2 minus 16 times 0 plus c will equal 6. Well, obviously, these bits are going to be 0. So we end up with c equals 6. Now, finally, we're asked to work out the velocity when t is 4. So now we can pop that in. So when t is 4, our velocity will be 4 times 4 to the 5 over 2 minus 16 times 4 plus 6. And let's get the calculator out for that one. So 4 times 4 to the 5 over, I need some brackets there, 5 over 2 minus 16 times 4 plus 6. And that brings us an answer of 70, and I'll just check the units. We're doing velocity, so that's 70 meters per second, or if you like to write it as meters to seconds to the minus 1, means the same thing. So meters per second. Okay, and that is us for this evening. I will post the next set of questions onto Instagram. Go take a look at them and come back and join me for tomorrow's live. All right, bye-bye.